Guys, got a little bit of a different video for you today. I've got my Tech2 scan tool here, and this is one of these knockoff designs rather than being genuine, and it's got a problem where it doesn't power up, and I'm going to show you how you can get that working in most cases. It could be other things, but I'm going to show you what the most common, most likely case is. So let me take this into the workshop and take it apart and show you. Got the unit in here on my workbench, and we're going to start getting it ready to disassemble. The first thing we're going to do is we're going to remove the VCI module. So you just move this little release lever off. That takes our VCI module out. And the next thing we're going to do is we're going to remove the firmware flash card, the PCMCIA flash card. So open this little door, slide this guy out. At this point now we've got 6 screws. Depending on which of the 2 manufacturers that made yours, it's either going to be a Phillips or it's going to be a Torx screw. You can remove these. It's, nothing really amazing about this except this guy that has this little warranty label on it. I'm going to kind of salvage this, and I'm going to use a very small, tiny regular head screwdriver to just gently get this guy up so I can get a pair of tweezers in here. And then I'm going to stick this on an adhesive backing because I want to kind of preserve this. And then also down here, and it's up to you guys if you want to do the same thing. Inside here, there's another one. It's one of these kind of stickers that's like on your license plate sticker that's designed to fall apart to prevent tampering, or to show tampering rather. And again, I just like to preserve these kind of things. It's just a style thing. You can toss it if you want. All right. Let me go ahead and remove the rest of these Phillips screws, and then we'll take the case off. These 6 screws loose. Just put some Scotch tape around where they go, because I'm just going to leave them inside so they don't get lost out here on the bench with everything else that's going to be going on soon. Once all 6 of them are loosened up, this guy just lifts straight off, and then you're going to want to flip it. It's part of why we put the tape on it. This keypad is attached by a couple of ribbon cables. What you want to do is just get your finger in between here, just gently pull them out. Okay, that'll remove this top piece. And then we're going to set it on a nice soft cloth here just so the clear plastic doesn't get scratched. And then just going to reach down here and pick up this. It fell down, so this is our strap that fell off. We're just going to kind of leave this on here. Whoops, get it where it goes. This is exactly why we're doing this, so we remember the way it went on. Okay, so this is the unit, the logic unit. The next thing we're going to need to do are these 4 Phillips screws that hold the LCD screen in place. And the most important thing I can tell you about this part is don't scratch or damage this top part. It's just a very, very thin, fragile blue film placed up here that gives it the blue color, but then underneath it's also the LCD screen itself, and it's very fragile. You gotta remember this is not the highest quality parts, which is why we're doing this in the first place. Okay, so we got this guy off. With these 4 out, this whole thing is going to lift out. You got a couple of jacks on the side, the RS-232 and the RS-485, and they're just kind of stuck underneath the casing here. So when you lift this out, just kind of gonna give it a pull up and over, and it comes right off, as you can see. So now I'm going to move the case unit out of the way, set that aside. Okay, now the thing we're after here, and it depends on your unit. I've seen 2 of these knockoff designs. The one I have here is got a ribbon cable. I'll just take a little baby cloth here and protect this as I fold it over. Got a ribbon cable that's soldered on here, and then this is the main logic board, and this is where we're going to be doing the change. Fold this over, and then very gently I'm going to flip this over like this. This is the guy we're after. This is a knockoff of the DC to DC converter that GM and Hewlett-Packard originally put together with some vendors for the original Tech2, and Vetronix just continued making that, and then Bosch after them. It's a very inferior design. We're going to replace it with this part. This is a Chinese company but they manufacture something that's very, very close to the original. You can't get the original. This is why they probably went with this kind of knockoff design, but it's expensive. This product probably cost you about 20 bucks, and for what they were trying to do here, that was just out of their price range. So all we're going to really do here is we're going to desolder this component, and then we're going to solder in this component. So I'm going to flip this back over very gently, and I'm going to take a moment here to identify the various pins. Right. So if you look at the back here, what we're looking for is we've got a design with a 3 and 3. And what I'm going to do is probably going to be hard with these capacitors. Let me take a minute to get something I can mark these for you, and then re-show this. All right, so I've got the part inverted here to show you this. So you can see there are 6 terminals, 3 that are spaced close together and 3 that are spaced far apart. And then the 3 that are spaced close together are in this row here, here, and here. And just to make it a little easier, let me put this magnifying glass here. So we got this guy here, got this guy here, we got this guy here. And then for the 3 up on top, we've got this guy here. Now notice here the knockoff doesn't even make a connection which the original board called for, because the clone of the DC-DC converter doesn't use this feature. And then here's the 6th one right here. So all we're going to have to do here is we're going to desolder these 5 and then solder in these 6. So let me get my gear set up to do that, and we'll come back. So one of the things I noticed was these little pins on this knockoff converter they've done are a little bit bigger than what would go on my desoldering tool, so I'm going to have to do it the hard way. I have to do it manually with the desoldering braid instead of the tool I normally would use. I'm going to take a little bit of some flux here just to make things easier. And then I'm going to get my destatic on. Not damage anything while we're doing this. Go ahead and get my tip tinned. I'm not going to show you all 5 of these because obviously this is something that is just prep work for the job. The gist for all 5 of these is going to be to heat the solder up, you know, to a point where we can wick it off. This guy's going to sink a lot of heat. It may take a while to get in there. A long while. There we go. You can see it's starting to wet up. So this is probably going to be the hardest part of this job, is getting all of this hot enough in order to desolder it this particular way. So that's basically the gist. You're going to go down and wick off all of this from all 5 of these very carefully. Like I just said, you're going to have a lot of heat because of the thickness of these terminals, and then the heat sink on top of this device. It's soaking a lot of heat. Alright, so let me keep going. I'm going to get these 5 off. And again, while you're doing this, make sure you don't accidentally hit your iron into these 2 connections for the keyboard and melt and deform them. Just go nice and slow. I'm going to go and do the same, get all these off, and then we'll come back. Okay, guys, turned out to be taking more heat than I wanted to use to go that way with those studs at this DC-DC converter that these guys in China came up with had. So what I decided to do instead is to remove it in pieces, because I'm not going to keep it or anything. So I took my X-Acto knife and I went around here and I worked my way around until I had separated the heat sink from the top of this board. And then what I did was I took my gun, or my iron rather, and I worked each of these one at a time, heating them up so that I could move them out of the way. And what I did, if I can find it here, don't need much here except a toothpick. Just worked a couple of toothpicks under here while I heated it up on each side until I had gotten it loose. In fact, I was just about to do this last one, so Just kind of heat the stud up and use the toothpick to remove it. On the other side, to keep some tension on it, I just took an old plastic putty knife and kept that under there. You want to use something plastic so you don't damage anything underneath. And what I'm going to do now is I'm going to remove each of these studs individually. That way we don't take a chance of doing any damage on the other side of the board. So depending on whether you have it, I understand that some of these, there's two kinds of boards out there. One has the heat sink, one doesn't, that I've seen. Usually the one that has the heat sink, the PCMCIA flash card cage here, has these pin-through hole, has a pin-through hole design like you see here. And the other type has like a card edge connector. So if you don't have the heat sink, you should just, I think, just go straight for what I just did here with these studs. But you're going to have to remove it, it looks like, if you're going to do what I did. But you can see that all this discrete componentry was designed up to replace what should have been just something like this. And I imagine at the time they originally knocked these off from Hewlett-Packard and General Motors, and then later Vetronix, and then later Bosch, this was the cheaper route to go, because this part was not sold to anybody else. But now it's knocked off for other reasons. So let me remove these five studs. I'll get this cleaned up with some of this epoxy that they let drip all over the board, and get the new part in. I'll tell you some of the stuff we're going to do to fix this guy up. You can see I've got 4 of these studs out right here, and they take a lot of heat because they're brass, and I've set my iron to 450 degrees Celsius just to make this go a lot faster. I've got the last one here to show you how to do. I just lay it along the bottom here, along the thicker edge. I'm using this, it's probably not the best tip for this, but couldn't find my chisel tip. Set this guy on here until he heats up enough to start moving. As soon as you see him move like that, you can stick a pair of pliers in there and he comes right out. So that's how I remove those. And again, I think that's what you're going to have to do with this particular style that has this heat sink on it. It's the only way to get enough heat without damaging the delicate parts that are on the other side. So what I'm going to do next is a couple of things. So I'm going to clean up the spilt kind of epoxy here. You can use your fingernail to get some of it off, and then I'll use something else to get the rest of it. But the other thing I noticed when I had this thing open is, you see this kind of discoloration around this this soldering that was done here. It's a little bit more evident if I flip it over. You can see the kind of discoloration along the pins of this edge connector for the VCI module. And here are the pins soldered in for the PCMCIA flash cage. Here are the pins soldered in for the RS-232 and the RS-485 ports. This is some residue left over by the flux that was used in the Chinese factory. There's a lot of people that say, hey, you can leave this kind of stuff on. This looks like a type of no clean flux. But depending on the quality of it, it can introduce oxidation later on, and this could be a reason why these things are not so reliable longevity-wise. So since I've already got this apart, I'm going to have to be cleaning up from what I did here on this other side. It's going to clean up some of the solder around these holes where we removed this. And I'm just going to go clean up all of this as well, and even touch up some of these connections just to make sure they're all good and I don't have any broken solder joints, so we don't have to take this thing apart again. I'm going to clean this up with some flux remover, and then clean the whole board with a special kind of alcohol. Now normally I try to use like a 99% alcohol. I don't have it right at the moment, so I'm going to go with a 91. This is really not the ideal one, but 99 if you can get it. You can get it at your pharmacy and special order it. If not, 91. Never anything lower than 91 though in electronics. There'd be too much water in it, and there's too much of a chance you'd miss something getting underneath the component, and that'd cause the oxidation we're trying to get rid of with this anyway. So a toothbrush and flux remover, a toothbrush, and some alcohol. I'll get started on that and I'll show you what it looks like when I get done. This looks a lot better. I had to get my fan going here to get some of these fumes away, and this is still drying a little bit, but we've got this oxidation from the flux used in the Chinese factory off of there. I feel a lot better that this is going to last. I touched up some of these that were not really good joints, so I feel like that's put some mileage on the device that way as well. We've got our connections that we're going to solder in nice and clean, and we've got the mounting on this side nice and clean. And again, this guy's going to sit right here. And you can see there's an outline for it on the circuit board. I just decided to make a different kind of part. Get this guy soldered in. A little piece of paper here. Get them pushed up. I flip the board over. Point out something here. Now, so since these holes are a little larger than before, we're going to do a solder along the, going to wet it along the side to get it caught first, and then we'll do a little bit on this side. We don't want to do too much and have it run down. So just because the holes are larger than the pins is why we're going to have that problem. All right, so I'm going to solder this in, and then we'll take a look at it afterwards. We'll get it put back together, and then we'll show how this fixes the problem. I'll put this on pause and come back. All right, we've got it soldered in. You know, we soldered in. This has got the connection that is on the board but was missing from the previous cloned part. And we've got them all situated and ready to go. Give you a close-up here so you can see the part. It's a Mornsun. You can actually see the PDFs of these online. It's a legit company that makes these. It's a knockoff of the kind that was originally used that came out after this knockoff Tech2 was done. That's probably why it wasn't incorporated. There's a couple of parts like this. There's another one too from a company called Recon that will work, and I'll put the number of that on the bottom. But this is the one I've seen, VRB 1205LD-15W, or this is the most recent version, Revision 2 R2. Either of those, either the one with the R2 or without, will work. So now let's reassemble it. So I'm going to move this over to the side here, and we're basically just going to reverse what we did earlier. Turn this over, bring over our base. Okay, and again it goes in this way. Again, we're trying to protect our LCD. Get your RS-232 and 485 ports to line up, and this will sit down just fine. We'll uncover where we have the LCD protected. We'll put our 4 Phillips screws back in, and again, depending on where yours was made, these may be Torx screws. I've seen Torx screws used on the back cover on some of these. Quality is about the same on the two types I've seen. Again, the easiest way to tell them apart, I mentioned, was on the PCMCIA flash card cage, whether it's got a card edge connector or that pin through a hole design like I have here. This is just the one I've had most recently. Can't really work on these older GM cars, in my opinion, without something like this. It's just a must-have tool. Okay, we got that in. We have one of our Velcros came off here. Let's line this guy back up. The easiest way to remember on these is the larger piece, the larger loop, goes towards the bottom. The smaller loop goes towards the top. Okay, I'm going to give a little blow of canned air to get some dust out of here. Most annoying thing for me would be if we had something underneath this thing, I'd want to take it apart again and get it out. So let's make sure we don't have that. All right, now we're going to go back and we're going to put these 2 keyboard cables in. Just give them a pinch. The ends are harder than the top. The top part's kind of fragile. The end's a little bit more robust. But you can feel it slip in. Just line the pins with the ribbon connectors up. Then get your Velcro loops inside the 2 plastic studs. Okay. And then as you flip it over, the other thing that sometimes gets a little messed up is the flash card door. Might have to lift it up a little bit to get it in the correct place where it's going to open and close properly. All right, and then we can take off this tape that we used to hold these screws in place earlier. So they're all there for us to tighten down. I won't bore you guys with that. Let me go ahead and get these tightened in. We'll come back and we'll run a diagnostic check and make sure everything's good. Okay, we got these snugged up. I'm not going to put my warranty sticker back until I'm sure we're all good here. Next thing I'm going to do is I'm going to put my VCI module back in. You see this this guy goes through these grooves. Slide them all the way over. And you can use him to push it down. I like to seat it manually and then lock it in place. Now we're going to open up put our flash card in. It goes this side down with the label facing forward, at least on this one that I have, with the directions are meant if you're looking in this direction. So you always want to go gentle with these. They're probably one of the most fragile parts of the whole thing. Half the time when you get errors where you get strange error messages or things won't read, 99% of the time it's these flash cards have shot. Alright, now I keep a separate bag with my diagnostic components. I got a diagnostic adapter that either goes on the end of the DLC cable or it can plug right into the VCI module. We got our AC power adapter, and we got our RS-232 loopback. So we're going to power it up here at the bench rather than in the vehicle, just in case we've got any problems. Powering it from down here. All right. And you know, the system initializing wrapping around, this seems to be a common issue. Sometimes it's centered, sometimes it's not. That's nothing. We passed our post test and we've come up. So that's a good sign right there. I'm going to stick my RS-232 loopback adapter into the 232 jack. They never did make a RS-485 adapter. And then rather than hooking up my DLC cable, I'm just going to plug the diagnostic guy right in like that. And we're going to go down to tool options. And we're going to run self-test. And we're going to run automated main printed circuit board and VCI. And we're going to have to go through this keyboard test. I don't expect there to be any problem with that, but we'll run through it anyway. Make sure you turn the shift key off before you continue this part of the test. Okay, yes, no, down, up, left, right, enter, exit. Okay, we've passed. Now we're going on to the next test. There's a screen test, screen video memory. Detected the PCMCIA card. The dots down here indicate that we're running the test. We're waiting to see that we get a total pass of 0 with no failures. Turn the soldering iron off back there. All right, we've got our pass. Now we can take a look at the main details with the soft key. We're missing the loopback on the 45. We know that. We don't have a PCMCIA card in the other slot. We know that. Everything else passed. That's great. We're going to go back. We'll take a look at the VCI test. Okay, everything passed. This HBCC, always ignored. I've never seen it say anything but ignored. So we're good. Now we're ready to try it in the vehicle and see if all this was worth it. Power it down. Unplug this. Take off our loopback adapter. Take off our diagnostic adapter. We'll reconnect our our DLC cable and our OBD2 adapter, and we'll try it in the vehicle. Let's give this guy a shot. Fire him up. Now that we've got him hooked back up, I got the engine running. Just want to run through some checks. See the power on self-test passing, and we're coming up with our firmware. Going to go into diagnostics. This particular vehicle we're going to be testing on right now is a 98 pickup. This one's got an L31 V8, and it's a four-wheel drive vehicle with a 4-speed automatic, and it's a 3/4 ton. And I'm going to pull up the data display and make sure that I'm getting live data from the engine okay, and I am. See RPM fluctuating here. Everything's looking good. Let me get back out. Take a look at transmission data display. Make sure that's working. Okay, great. So we've got this guy back in service. What we got now is actually a better part. The part we put in here has a higher wattage rating, 15 watts versus 10 watts from the original that would have been in from the original Tech2 design even. 3 amps instead of 2 amps, which would have been a normal, even from the original GM Tech2. So much more reliable part. We cleaned up those solder tracings and got this to be a lot more reliable. So, and especially this part here. So, you know, exiting out here, this button, the power button, a lot of these chips, if you put them in here, these converters won't actuate this. It'll be on all the time. And we actually want one like the Mornsun that we used that has a remote on-off capability to make it be just like what we had. So this guy's back in service and a lot more reliable than he was before. I hope this helped you out. Thanks, guys.